Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Ratio Skyscrapers, and it's by Lorena. And here are the rules. Sudoku, place the digits 1 through 9 once each in every row, column, and marked 3 by 3 box. We also have a cipher, where different letters inside and outside the grid represent different digits. The four symbols, the green heart, the blue square, the yellow circle, and the red diamond stand for four distinct letters. Oh, interesting. Okay. So the symbols act as letters too. So they stand for four distinct letters. We have the letters A through I, and then we have C and E here. Skyscrapers. Digits outside the grid count the number of digits visible looking into the grid from their vantage point in their respective rows. Digits are visible when they are larger than all the digits before them. So as an example, let's use this. So say we had something like 2, 5, 4, 6, 1, 8, 7, 9, 3. We would celebrate because we have a 3 in the corner, but the digit outside in this, so the A in this row would be the digit outside, and it counts the number of digits which are visible looking in this direction. So it would see the 2, it would see the 5, it would not see the 4 because 4 is shorter than the 5. It would see the 6, it would not see the 1, it would see the 8, it would, okay, so it sees the 2, 5, 6, and 8. It does not see the 7 because the 7 is behind the 8, and it's considered shorter than the 8, so you would not be able to see, essentially, a 7-story building behind an 8-story building. And then you have a 9, which it sees, and it does not see the 3. So therefore, this A would essentially be a 5 if this were the example in the row, right? Because you see specifically the two digits 2, 5, 6, 8, and 9, and you do not see any of the other skyscrapers. So that's how skyscrapers work. Ratio. A digit inside a black dot indicates the ratio between two digits separated by the dot. So the green heart, the blue square, the yellow circle, and the red diamond all represent four distinct digits. So the ratio between this, the digit inside the black dot indicates the ratio between the two digits. So let's say that the green, the green heart was actually a 3. Then that would mean these two digits would have to be in a 1-to-3 ratio. So if you knew this was a 3, and you knew that that's not 3 in the corner, that's 3 outside the corner. Anyways, if this were a 3, and you knew the green was a 3, the green heart was a 3, this would have to either be 1 or 9 here to maintain the 1-to-3 ratio. If the heart were instead, say, a 2, then you would have to have a 6 here because you would know it would be a 1-to-2 ratio. Obviously, it cannot be 4 with a 3 there, but say it was a 4. Actually, you could have like 5 or 7. If the green heart was a 7, then this would have to be a 1 or a 7 or a 7 or a 1 here to maintain a 7-to-1 ratio. So all the ratios inside black dots, all the digits inside a black dot indicate a ratio between the two digits separated by the dot. Note, answer check checks for the values of the letters A and I outside the grid. So make sure to fill those in too. Okay, so to finish the puzzle, you need to actually correctly place all the digits, including the ones outside the grid. But those are also an extent, those have to be the digits 1 through 9 also, because they are all digits and they're all distinct, because different letters represent different digits. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, since we know this is distinctly 1 through 9 for all these digits, what are the ratios you can have? Well, everything is in a ratio except for one digit. The only digits that cannot be in a ratio, except for with 1, are 5 and 7. So this I must be a 5 or 7. Therefore, the 5 or 7 actually has to be one of these ratios. It cannot be yellow, because if it were yellow, this would also have to be in a 5 to 7 ratio. And the only 5 to 1, 1 to 5, or 1 to 7 ratios you can have are specifically 1 and 5 or 1 and 7. So therefore, this cannot, so it's either red has to be, so yellow cannot be a 5 to 7 ratio, 5 or 7 ratio. So yellow has to be either 2, 3, or 4. 6 would have to be with 1, but we know the 1 has to be with the other 5 or 7 to form a 5 to 7 ratio. Because everything else, every other digit, is in a ratio. And we know both 5 and 7 can only be in a ratio with 1. So, and there's only one 1 possible because these are all distinct different digits. So the other 5 or 7 has to be with a 1. This cannot be 5 or 7. These can't be 5 or 7. Actually, this can't be 5 or 7 either. The 5 or 7 has to be on the end here. So it could be 5 or 7's here. 5 or 7 could be here. 5 or 7 could be here. We don't know, though. Excuse me. The 1 has to be either next to the 5 or 7. So it's either here or here. Therefore, the yellow must be either a 2 to 1 ratio, a 3 to 1 ratio, or a 4 to 1 ratio. Let's see. And those are the only ratios we have left, right? Obviously, it can't be 1 to 1 because there are no 2 digits which are the same. You can't, I guess you could have a 6 to 1 ratio, right? If say this were the 1 of these would be 5 or 7, and the other one could be like 6, 8, or 9, which is possible. So we don't actually have a dual ratio. The yellow cannot be 4 in the 1 to 4 ratio because there's only, actually it could be. It could be 1, 4, and 2, 8. Never mind. Okay, so if the yellow is in a 1 to is 4, that would mean that this would have to be 2 and 8. And this would have to be 1 and 4 specifically, which is possible. Therefore, you would have 3, 6, and 9 here, which does work. So this could be 3 with 6 and 9 here. So that works if yellow is in a 1 to 4 ratio, right? Because then the 3 would be in a 1 to 2 ratio with 6, and then a 1 to 3 ratio with 9. Oh yeah, what are these digits? These have to be in ratios with each other, right? In multiple ratios with each other. So obviously it could be 1. But what other digits can it be? Can it be 4 is the question. 4 can only be in a 1 to 2 ratio with 8. It could be in a 4 to 1 ratio with 1 or another 1 to 2 ratio with 2. But that's not allowed because these are different numbers. The green heart and the blue diamond are distinct digits. So it could not be 4 in either of these spaces. And 5 doesn't work, obviously, because we already know that. 6 can only be, again, in a 1 to 2 ratio with 3, or in a 1 to 6 ratio with 1, but we know 1 has to be next to a 5 or a 7, so this can never be 6 in the middle. So that means 4th and above does not work, right? Because you could have, if you try to have 4, you would have to have it with 8, 2, or 1. And the problem is 1 can't be on an outside because it must be next to a 5 or 7. So 4 and 1 doesn't work. And if you try to have 4, 2, and 4, 8, they would have to be the same ratio, but these are all distinctly different digits. So you could have 3 in the middle or 2 in the middle. So 2 and 3 can be in the middle also. 2 and 3 are not multiples of each other. So therefore, the other digit has to be the digit here. Okay, so if you had 3 in the middle, okay, so if you had 2 in the middle of a digit, it must be next to 4, 6, and 8. Well, 3 would be the other digit, right? So you would have, if this is 2, this would have to be 3. Yeah, how would that work is the question. 3 could be in a ratio. Okay, so 9, oh, okay, 9 always has to be in a ratio with 3. Because that's, 9 can only be in a ratio with 3 and 1. That's actually probably a better way of putting it. So, well, okay, no, that's not true. So 9 is in a ratio with 3 or 1. 1 is one of these. 5 and 7 are one of these. So it could be 1, it could be 9, 1, 5, or 7. That's possible. And if whichever one that sees the 1, it only sees the 9 as a skyscraper. Because if you had any other digit in front of the 9, you would see that skyscraper and the 9, which means that you would see more than one skyscraper. So wherever the 1 is, which is either B or E, it has to see 9 in that cell. Therefore, E must be 1, 2, or 3. B must be 1, 2, or 3. So this is 1, 2, or 3. This can never be 9. Obviously, I guess. What other possibilities do we have? So, okay, so if you have a 3, you have it with 6 and 9, right? Because those are the only multiples besides 1 that it can be part of. Therefore, you would need a 2 here. The yellow could be 3, 6, and 9 here. That could work. And then this would be 2 and 4 or 2 and 8. Or 2 and... It can't be 2 and 6. So if 2 is outside... So say you had a 3 in one of these. If you have a 2 outside, it can never be with 2 and 6 because you know the 3 has to have the multiples with 6 and 9. So it would have to be either 2, 4 or 2, 8. Well, if this is 2 and 8, that's possible if this is specifically 1 and 4. Right, so if this is a 2, say this is 2, this is either with 4 or 8. This would then have to be a 4 to 1 ratio if this is 2 and 8, which makes this 4, 1 with 5 or 7. And that does work. So then this would be 3 with 6 or 9 here. If this is 2 and 4, then this would have to be a 2-digit number. So this would it cannot be 1 and 2. So this would have to be 3 with 6, and this is 9. And then this would be 1, 5, 7, and 8. Okay. If, however, this is 3 and 6, that means this is in a 1 to 2 ratio. So 1 can never be here, because 1 would have to be in a 1 to 2 ratio with 2. Actually, this could be 3 and... Actually, it would have... Well, it doesn't have to be. 3 could be with 6 or 9. So it could be a 1 to 3 ratio. But even then, okay, so that doesn't work. So if this is 3 or 6 or 3 or 9, this has to be a 2. And it cannot be 3 and 9 then, because that would force this to be 2 and 6, which we... Oh, actually, that does work. Hold up. Okay. If this is 3 and 6, that would force this to be 2, because you have to have a 1 to 2 ratio here, and you cannot have the 1 be with 2, because the 2 has to be the other middle cell here. So this has to be 2. This is 1. 2 would have to be with 4. And then this is 3 and 6, so then 2 would have to be with 8 here. So this is a 1 to 4 ratio. And then you would have 9, 1 with 5 or 7, or 9, 1 with 5 or 7 here. If you have 3, that's step 3 and 6. If you have 3 and 9, that means yellow is in a 1 to 3 ratio, which requires it to not be 1 because 3 is already taken. So it would have to still be 2, and this would be 6. Hold up. Okay, so let's go through the possibilities again here. We have 2 and 4. That means we need 3. This is a 1 to 2 ratio. It cannot be 1 here. It has to be 3, which means there's a 1 to 2 ratio. This is 6. This has to be 9 to be a 1 to 3 ratio. This is then 1 with 5, 7, or 8. And that all works. If this is 2 and 8, it can never be 2 and 6, I don't think. Right, because then the 3 doesn't have 2 multiples it can be next to. And 3 can't be next to 1 because one of these is 1, the other one's 3. So this could be 2 and 8, which would mean this is a 1 to 4 ratio, which forces this to be 1. This has to be 4 to make sure the 1 to 4 ratio, and this is 5 or 7. Therefore, this is a 1 to 4. This is 1 to 5 or 7, and this would be 3. 6 or 9. Either one works in either scenario. So that's 2 and 8. If you have 3 and 6, this is a 1 to 2 ratio. So it cannot be 1 and 2 because the 1 and the 2's have to be in the middle. So this would have to be 2. 4. This is 3 and 6. So this can't be, this has to be 2 and 8. Which means 9 is on the outside. And you have a 1 and you have a 5 and 7 on the other outside and 1 in the middle. If this is 3 and 9, that would mean you have to have a 1 to 3 ratio here, which means this still can't be 1. So this would have to be 2 and 6, and you'd have 2 and 4 and 8 here. This is a 1 to 3. This is 1 to 3. This would be 1 to 2 or 1 to 4. This would be, okay, so this cannot, okay. Hold up. If this is 3 to 6, this is 2 and 4. Okay, so, okay, sorry, 3 and 9. Sorry, 3 and 9. This is a 1 to 3 ratio, which forces this to be 2, 6. If this was 2 and 8, you could not have a 4 in either of these areas, because that would lead to a 1 to 4 ratio between the 1 and the 4. And 2 to 8 would be a 1 to 4 ratio, but it would be a different digit than the other digit here, which is not possible. So if this is 2, 6, this is 8. Sorry, this is 4. Which makes this 1, 8 with 5 or 7. So C is specifically 5, 6, 7, 8, and 9. Okay. That's not that helpful. So 9 has to be one of these 3 digits. 9 has to be either... actually, that's not true. It could see... if it's not 1, it could be something like 9 here, all the way here. This could, or even at the end, right? Because you could see 7, 8, and then 9. That could work. This, that's what we see though. This sees at least 5 digits, or sorry, 5 skyscrapers. So it must be that 9 can only be one of these 5 digits, right? If 9 is in front of these, it would not see the 9 digits here. It's not, if we had 9 in one of these, it would not be able to see 5 skyscrapers or more. Similarly, this only sees 5, 9, 9 can only, this sees at least 5 skyscrapers here, which means that 9 could be at the earliest here. So 9 has to be one of these 5 in row 3. 9 has to be one of these 5 in row 1, which means where is the 9 in row 2? It cannot be any of the digits in in boxes 2 and 3, because we already have 2 9s in those boxes. So this cannot be 9, which means this can't be 9. This is 5, 6, 7, or 8. Therefore, the 9 must be one of these 3 digits there. D is specifically 4 or 6. Okay, so this can never be 9 here, because if this is 9, the 9 has to be at the end, right? Oh, actually, yeah. Wherever the 9 is in this skyscraper clues, the 9 has to match the end. So this can never be 9, because if that were not 9, so there has to be one row that sees all the digits in exactly the same row, in exactly counting order, because you need to be able to see all 9 digits, because one of these digits is a 9, right? So it must be 1, 2, 3, 4, 5, 6, 7, 8, and 9. This cannot be 9, because 9 would have to be the last digit. This could be 9, this could be 9, and this could be 9. So 9 in column 9 has to be either here, here, or here, right? And correspondingly, actually, where the 9 is must match wherever, whatever digit this is, right? So whatever this column is, that's the column that the 9 is in. And the reason is you need a 9 in every column, right? Well, if you, and you have each of these skyscrapers count every, must be every digit, right? So you have each of these rows sees a skyscraper. One sees one row sees one row sees two, one row sees 3, 4, 5, 6, 7, 8, and 9. Well, to see all 9 skyscrapers, you have to see all the digits from 1 through 9. To see 8 skyscrapers, you must see 8 digits, but you can't have 9 be the last digit. So the 9 has to be the 8th digit for the 8 skyscraper clue, right? Same with 7. 7 can no longer be in the 8th or 9th positions because none of them, because 9 is already accounted for in those columns. So then 9 has to be in the appropriate columns. So this cannot be 9 because this has to match the 1 or 3. This could, any of these 3 could be 9 because they match the 1, 2, or 3. This has to be 4 or 6. So the 9 has to match there. And this then cannot be 4 or 5 because this is specifically a 9 has to be in one of these two cells. Well, in the box 5, there can no longer be a 9. So this can't be 9. These can be all 9 as possibilities. Similarly, one of these is, so you cannot have, you could have 3, 6, and 9. So if this is 3, 6, and 9, this is 3, this is 6, and that's 9. So this can never be 6 if that's the case. And if you have, one of these has to be a 5. Because if you don't have a 5, where is the 9 going to? Actually, I guess it could be 6 here. So this is 5 or 6. This is either 6 and 9, which would make this 4. So if this is 3, 6, 9, this becomes 1, 4, 7. We know the 9 has to be one of these 4 digits here. 5 and 7 could be where the 9 is here. If this could be 3, 6, 9 here, that's fine. The other possibility here, okay, so let's go back. What are the possibilities? Again, if you have 2, 4 here, that would mean 9 has to be here and 9 has to be here. Well, that means where is the 9 then in the rest of box 9? Can't be any of these because we already have 2 9s and 2 and 4. So it must be one of these 3 cells, so it has to be 7. So then this would be 7 here. If this is 2 and 4, we have to have a 3. Again, this could be 3, but this I think also could be, oh no, this is a 1 to 2 ratio. So you can't have 1 here. This has to be 3. So this would be 3, this would be 6, and this would be 9. Where would the 9s be then? The 9s would be 3, so this would be 9 here, 9 here, and 9 here. This would then be 1, 5, and 8, and either of these could be 5 or 8. So this would be 1, this would be 5 or 8, this would be 5 or 8. Which means the 9s would have to be either there or here. Also, doesn't it have to be in a certain order? So if this is 1, no, not necessarily. It probably is, though. Okay, yeah, if you have a digit, so okay, let's just go through the what, in general, what it can be, right? Let's clear out the entire grid so that we can see this obviously. if you have a 9 here, so say you had a 9 here, this becomes 1, it must be 1, 2, 3, 4, 5, 6, 7, 8, 9, because it has to see all 9 digits here. What about the 8, whichever 8 is here? Let's just randomly put it here. Say this is 8. This can never be 1, and it has to see 8 digits. Well, that means that forces this to be 2, which makes that 3, 4, 5, 6. We know 9 has to be here, because 9 can no longer be here. So, what are these digits? It has to see every single one of these. So 1 cannot be here. 1 has to be here. Then that forces us to be 3, 4, 5, 6, 7, and 8. So similarly, if we find a 7 here somewhere, what digit can that be? It cannot be 1. It cannot be 2. It has to be 3. Where is the 9? 9 can't be any of these two digits. It has to be here. And it must be able to see every single one of these digits. So it cannot see 1 and 2 in any of these cells. So therefore 1 and 2 have to be here. This can't be 1 because of that 1. So this is 2, which makes that a 1. This must be then 4, 5, 6, 7, 8 to be able to see all the cells. And continuously it will do this. So you always have, starting from the 1 and sort of wrapping around, it'll always go in the order 1, 2, 3, 4, 5, 6, 7, 8, 9. Just from what we've seen here, right? So you cannot have, you know where, based off where the 9s are, you know exactly where each other digit has to be, right? So again, this could be 1, 2, or 3. This is 5 or 7, which means either this is 9 or this is 9. Either way, we know these have to be the 8s. These have to be the 7s. These are the 6s. 9, 8, 7, 6. These are the 5s. These are the 4s. These are the 3s. Then we have 2s and we have 1s. So these have to be essentially what the order is, right? So 8 has to be one of these two digits. 2 has to be one of those two digits. And we have 5 as one of those two digits. That's interesting. This is, again, is 1, 2, or 3. Since this is 1, 2, or 3, it cannot be 2. So this actually has to be 1 or 3 here. So therefore, this is 1 or 3. This is 1 or 3. If this is 1, this becomes 2, 3, 4, 5, 6, 7, 8, and 9, which would make that an 8. If this is 3, that would make this 4, 5, 6, 7, 8, 9, 1, 2. But 2 can't be here because one of these must be a 2. So that doesn't work. Therefore, we know this has to be 9. This is 9. This is 1, 2, 3, 4, 5, 6, 7, 8. That makes this an 8. E has to be 1. So the other 5 or 7 has to be one of these. 8 can only be in a 1 to 2 ratio or a 1 to 4 ratio. And it cannot be in a 1 to 2 ratio because, actually it could be in a 1 to 2 ratio. I forgot about that. Huh. Okay. Well, we know, okay, so this 4 means this can't be 4. This can't be 5 because 9 can no longer be here. So this this can't be 7 because 9 can no longer be here. So this must be 5, which makes this 9, 1, 2, 3, 4, 5, 6, 7, 8. We know these digits are 1, 8, and 9. So the 9 has to be one of these 3 digits. Well, the only one that can be in a multiple ratio is 8 and 2 because the 1 has to be somewhere else, has to be here. So this must be 2 then, which makes this 9, this 8, 1, 2, 3, 4, 5. That's not 6. This is 6, this is 7. So this is 1. This is a 1 to 4 ratio, which forces this to be the 4. So this is 4, this can't be 5, this is 7. 1 sees one digit, so this is 9, 1, 2, 3, 4, 5, 6, 7, 8. This is 3. Which means the 9 has to be here. So it's a 7, 8, 9. 1, 2, 3, 4, 5, and 6. C has to be 6, which makes A 9. And then we just fill this out. So 4 means that 9, it sees 4 skyscrapers, so 9 has to be in the 4th spot. 9, 1, 2, 3, 4, 5, 6, 7, 8. This means 9 has to be in the 7th spot, so it's 9, 1, 2, 3, 4, 5, 6, 7, 8. 9 is in the 6th spot here, so it's 9, 1, 2, 3, 4, 5, 6, 7, 8. 9 is in the 9th spot, which means this is 9, 1, 2, 3, 4, 5, 6, 7, and 8. And that's how you solve it. Yeah, I didn't really notice that this had to be in the order 1 through 9, specifically throughout the row, until fairly late. That makes things fairly trivial, actually. Pretty cool, interesting way of... interesting restriction, I should say. Especially because since these are unique digits, that forces this restriction in itself, right? I don't know how expandable these type of puzzles are, but this was very cool, actually, seeing the interactions between the different digits and the numbers. Anyways, I hope you enjoyed watching this solve, and I'll see you next time on Frank Puzzles. Take care.